topic that the teacher is asking us again.
About the number theory. The assigned topic given to us is all about the prime numbers.
Prime numbers. What is prime numbers?
Prime numbers. A prime number is a whole number greater than 1 whose only factor are 1 in itself. A factor is a whole number that can be divided into another number. The first few prime numbers are 2, 3, 7, 11, 13, 17, 19, 23, and 29. Numbers that have more than 2 factors are so-called composite numbers. The number 1 is either prime nor composite. Prime number can be used for another number of reason. For example, if type of cryptography will use prime numbers. The mathematical proof, which demonstrated in ancient time by Greek mathematicians Euclid, validated the concept that there is no largest prime number as the set of natural numbers, that is, n is equals to the set of 1, 2, 3, and so on. Proceeds, prime numbers do generally become less frequent and more difficult to find in reasonable amount of time. Now, how to determine if a number is prime? A computer can be used to test extremely large number to see if they are prime, but because of there is no limit how large a natural number can be, there is always a point where testing this matter become too great a task, even for those most powerful computers. As an example, the largest known prime number in December of 2018 was at 24,862,048 digits. Various algorithms have been formulated and attempt to generate ever larger prime numbers. For example, suppose n is a whole number, and it is not yet known if n is a prime or composite. This example called the prime factorization. So we're going to find the factorization of 255. So we know that 5 times 45 is equals to 255, where 5 is a prime and 45 is not. Then we're going to factorize the 45 into 5 times 9, which 5 is a prime and 9 is not. So we're going to factor again the 9 to 3 times 3, which is 3 is a prime number. So the factorization of 255 is 5 times 5 times 3 times 3, or 5 squared times 3 squared. Now that you know what is prime number, can you identify what are prime numbers?
Prime numbers. Oh, prime numbers are 2, 3, 5, 7. But how can I identify if that number is a prime number? So in order to know if that number is a prime number, we will use the 3 famous prime in solving the equation. So the Mersenne, Sophie Germain, and Fermat prime. We will use these 3 famous prime in finding if the number is a prime or not.
Mersenne prime is a number that must be
To
reducible
the form
any form.
2n minus 1, where n is a prime number. So this is the formula of Mersenne prime. M sub n is equals to 2 raised to n minus 1. So for us to be able to know the prime numbers, let's have an example. So m sub 2 is equals to 2 raised to 2 minus 1 is equals to 2 raised to 2 is equals to 4 minus 1, and 4 minus 1 is 3. So the answer is 3. Next is m sub 3 is equals to 2 raised to 3 minus 1, then 2 raised to 3 is equals to 8. So 8 minus 1 is equals to 7. m sub 4 is equals to 2 raised to 4 minus 1. So 2 raised to 4 is equals to 16. 16 minus 1 is equals to 15. So next is m sub 5 is equals to 2 raised to 5 minus 1. So 2 raised to 5 is equals to 32. So 32 minus 1 is equals to 31. So last example is m sub 6 is equals to 2 raised to 6 minus 1. So 2 raised to 6 is equals to 64. 64 minus 1 is 63. So thus the 3, 7, 15, 63, and 31 is a prime number. So no, not all of these are prime numbers. So 15 is not a prime number because it can be multiplying 3 and 5. And also the 63 is not a prime number because it can be multiplied into 3 and 21 and 8, 7 and 9. So 15 and 63 is not a prime number, and 3, 7 and 31 is a prime number. A Fermat prime is a Fermat number that is also prime. A Fermat number Fn is of the form 2m plus 1, where m signifies the power of 2, that is m equals 2n, and where n is an integer. So this is the formula of Fermat number. F sub n is equals to 2 raised to 2 raised to n plus 1, where n represents the real number. So in order to know if the number is a prime or not, let's have an example. So first example is 2 raised to 2 raised to 0 plus 1. So 2 raised to 2 raised to 0 is equals to 2 plus 1 is equals to 3. Next is 2 raised to 2 raised to 1 plus 1. So 2 raised to 2 is equals to 4 raised to 1 is equals to 4 again. Then 4 plus 1 is equals to 5. So next example is 2 raised to 2 raised to 2 plus 1. So 2 raised to 2 raised to 2 is 16. So 16 plus 1 is equals to 17. So last example is 2 raised to 2 raised to 3 plus 1. 2 raised to 2 raised to 3 is equals to 256 plus 1. So 256 plus 1 is equals to 257. So as we can see, all results are all prime number. So Sophie Germain prime if 2p plus 1 is also prime. The number 2p plus 1 associated with a Sophie Germain prime is called a safe prime. So this is the formula of Sophie Germain prime. 2p plus 1, where p represents the real number. So in order to know if the number is prime, let's have an example. So first is 2 times 6 plus 1. So 2 times 6 is equals to 12 plus 1 is equals to 13. Next is 2 times 7 plus 1. So 2 times 7 is equals to 14 plus 1 is equals to 15. So let's find out later if the answer is a prime or not. So let's proceed to our next example. So 2 times 8 plus 1. So 2 times 8 equals 16 plus 1 is equals to 17. So next is 2 times 9 plus 1. So 2 times 9 is equals to 18. And plus 1. So 18 plus 1 is equals to 19. So here, this is our final answer, the 13, 17, 18, and 19. And now, the question is, are all these results is a prime number? So, no, there is one result that is not a prime number. So, which is the 15. Because 15 is not a prime number because it is it can be multiplied to 3 and 5. So 15 is not a prime number. Only the 13, 17, and 19 is the prime number. So those are prime numbers. JP, can we use it in real life situation?
Yes, we can.
But how?
Bye. Now, how can we use the prime number in real life? We can use prime number if we want to make an activity, namely, group yourselves. Every prime number cannot be even except for 2, for example. If we want to make this activity, we must make use of prime numbers because we know that there is no other factor of prime number except 1 in itself. Furthermore, we will pick the 23 for example, and because we know 23 is a prime number, and whatever number you pick except 2 cannot be even, and there is always a student who does not have a partner. So that is a example of a prime number in a real life scenario.
So those are the prime numbers in a real life situation. So it can be like this too. So example of a prime number in a real life situation is at a time when email and technology are not fashionable. So what they did to communicate was they made a code that only they could understand, especially during World War. So in order to communicate with their colleagues, they use a code. Thank you, Jamie. Now I know what are prime numbers and what are prime numbers in real life situation. Thank you very much. Bye.
Bye.